This is also not happening.
Yeah, this is. Okay, I'm going to send that.
You send me the link. I'll email it to all.
Yeah.
That ending with you,
Mm.
ending with you.
Yeah.
Hey, come. Or why? One second, one second. One second.
Yeah.
For me, it was ending with you. It's already open. Okay, why, right?
Mm. Ah.
No, it is not defendable.
Yeah. I think it started. Hi everyone. Could you please, someone please confirm that you are able to hear and you're able to see my screen? You can confirm. No, no, can you see the comments? Okay. 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 Yeah. Right. Yeah. Okay. Thank you so much. This is really at the so it is. It has given some problem while starting live YouTube video. I'm very sorry to everybody for wasting of your time. So I hope my voice is very clear and you can see my screen clearly. So if you have any issues with the video or audio, please message in the chat window. And as the session goes on, if you have any questions, please you can ask in chat window. So in meantime, we will be checking the messages and we'll be addressing your questions. So by the way, welcome to the very first session of our series. this series is like concentrated mainly on people who are looking for jobs, especially for the freshers who are passed out or who are in colleges and looking for good placements. So, by the way, my name is Kamal. I'm going to be your trainer for the entire series. I'm a founder of Apt Computing Labs and I'm collaborating with the career group to give these presentations as well. So, and another some more details about myself. I'm from NIT Rourkela, passed out in 2008. Since then, I worked on many companies like Iconos. Maybe most of the people have not heard about that. It is a startup, especially for communications, the signal processing company. And then Huawei, Savari Systems related to automotive, Juniper Networks related to networking and security, Harman again on automotive, and finally I'm working for myself and I have my own firm that is Apt Computing Labs. So since last year I'm working on trainings, giving the trainings and handling the projects on especially cloud computing. Especially, the programming languages are like Python, C, C++. I'm also introducing to the people about Rust programming. So this is a small introduction about myself. Total overall, I have 17 years of experience. I have attended many interviews and also I took a lot of interviews from freshers and uh, from different category of the people, like with many years experience, and I shortlisted very few of them. So I have a lot of experience in taking the interviews, and I know what actually industries are expecting from the students, especially. Okay, so depending on that, we have come up with some of the list, what are actually highly demanded from the students. So I have observed many students or people without a proper planning. If they go and attend the interviews, it will be like failures most of the time. So we are here to help you to guide the path and what are the subjects and what are the topics you need to prepare a lot on. So this is the list related to preparation. So the first thing is like DSA, data structures and algorithms, system design, system programming, computer networks, RDBMS, and OOPS concepts. So just a second. Hello, Mahesh? Yeah, yeah. Okay, I started. Just a second. Yeah. So again, just I want a confirmation from you guys. Can anybody please message that you are able to hear me properly and able to see the screen? Yeah. Okay. So yeah. So yeah. So these are the topics which we are going to cover in this series of session. And the first thing is like data structures and algorithms. So in this session, today's session, we are going to introduce the DSA, some concepts, and coming to the system design. So whenever you attend any interviews, they may ask you to design some simple systems. Okay, so which are like they may ask you to design a simple web application. Okay, so you may have to so this is all about system design. So in the system design you may have to get hands on, like you can take one reference like how the WhatsApp is created. Okay, so how it is designed. So there you may have to come up with a lot of terminologies like a gateway, database, and like a distributed database. So authentication, authorization, um, so authentication, and a lot of things like you need to load balancing. Okay, so and routing. So a lot of concepts are there which you can leverage, and these concepts are very interesting. Like whatever the system you are going to design, you have to start designing with the block diagrams, sequence diagrams, flow charts, and then once you come up with all those diagrams, all the discuss about a lot of blocks, after that you can become confident on the system. Later on you can start designing the start writing the code. So whenever we uh, we, in interviews, the first question we ask about uh, the projects. So students or very in even experienced people, we ask them like, so what are the systems you have worked on? So could you please tell me about the overall design? So we should not ask the internal designs, low-level designs, like at least some overall designs we can ask. Depending on the way he explains, we can get to know how confident it is about the designing the system. Okay, so any candidate, if we need to recruit on board, we feel that he should be able to understand the existing design. So if he has some background, like already he had gone through some systems, then he can understand the design very well. Whatever in our company, whatever we work on, they can understand it in better way if they have already some idea. That is about system design. Coming to system programming, it is all about, if you learn more about Unix operating system. So Unix operating system concepts, or Unix like operating system, or you can say Linux operating systems. What are all? There are many concepts like process management, file management, and related to IPC. You may have to cover about threads. So even when the threads comes into the picture, what about the mutex locks or atomic variables? Okay, so these are all the concepts. IPC, when we come to IPC, what are all there? Pipes, or message queues, or shared memories, sockets. So you need to be very clear about these IPCs. Coming to file system, what is meant by inode? How the file system is stored in memory. Okay, so these are the concepts. And coming to the process management, so what is mean by a process first of all? And how do you, what about if you need to create a process, if you need to kill a process, okay, and if you need to execute a process? So these are all the concepts are very much important when you need to work on system level programming. For example, you writing the normal program is one level, and so like let's say like writing the functional coding. Okay, so functional coding is sense like uh, deriving the logic and writing all the functionalities. Come the next level is about system programming. So system programming is actually done by experts. So if if you know system programming, it means that whatever the application you're going to write and where it is going to run, is it going to run on Linux, Unix, or Windows, where operating system. So depending on the target operating system, you need to write these programming, these system programming. So if you know very well about operating system concepts, you can do very well in system programming. Even it is not only on Linux or Windows. It is also like writing the software on RTOS for embedded systems. So to write the software specific to the target operating system is also a very good skill. So if you have those skills, it is very good. I mean, it is a very big plus point. Coming to the computer networks, computer network is another critical skill required, especially for cybersecurity, or if you write any firewalls or network applications. In those cases, you need to be very strong in computer networks. You need to be very good in TCP/IP protocol. So you should be able to explain all the layers from uh, it's like a physical layer, data link layer, transport layer, sorry, IP layer, and transport layer, and application layer. So you need to explain about all these layers whenever how the packet comes to the computer, and how it is getting filtered in all the layers, and finally how does it reach a specific application. Let's say an application is listening on some IP and port number. So you should be able to explain if any packet comes over the Ethernet, so how does it reach a specific application which is running on some IP and port number. So a lot of application runs, application 1, 2, 3, lot of application runs on multiple port numbers. You need to explain how does these packets reach these applications depending on the IP and port number. And also there are a lot of protocols in IP, in transportation layer, in data link layer. So you can explore those things, like then you can understand the how the computers they talk to each other, and how do they securely transmit their data. Okay, so these are the protocols, like when you come to transport, like a TCP UDP, and you come to IPv4. So you need to at least get some idea on all the protocols, on all the in all the layers. Okay, so these are also expected. So when you go to attend any interviews which who are demanding the who are working on network applications, you need to be very strong in these topics. Okay, so along with these, you also need to learn about Wireshark. So one of the networking debugging tool used in industries heavily, and analyze the packets one by one. Okay, so and coming to RDBMS, relational database management system. So this is very important when you come towards saving huge data. And let's say this is a DB, and you need to load a lot of tables, and you need to derive the relationships between those two uh, uh, tables. Okay, and migrating one database to another database is another big task now. Okay, so you need to have at least some idea on SQL query. Okay, so whatever it is, like MySQL or Postgres. So there are a lot of database systems. So, but if you know SQL query language, then it is a plus point to work on database management system. Okay, and coming to OOPS concepts, like you may, maybe they may ask you to write uh, a simple class diagram, derive a simple class diagram, and hierarchy. What about the hierarchy? So what is the base class, what is the derived class, and what is the concept of inheritance? Okay, so lot of things, like what is the abstract class. So depending on the language, they can shoot these questions, and they may ask you to derived classes and its relationships as well, depending on the requirement. So nowadays, you see any programming language, so they all support OOPS concepts. OOPS. So it's like you take C++, Java, Python, right? So any other language, like now recently Rust is another programming language newly coming. It doesn't support classes, but you can achieve whatever the OOPS concepts are there you in Rust as well. So all these languages supports OOPS concepts. That is why it became popular. So if you need to write very complex applications, the programming language which you use should support OOPS concepts. So interviewer also wants to check these concepts from any student. Okay, so you try to have, so coming back to the slide. So we are anyway going to discuss about DSA now. These are all the fundas. I hope you have got some idea what is what, like what is system design, what is system programming, what do they expect actually, what an interviewer expects from you, from about all these concepts. Okay, so coming to DSA, data structures and algorithms, is the most important. So what are the topics are listed here? They are listed in priority order. The first one is a DSA algorithms. It's like if you are very good in programming, writing the efficient code. So DSA tests your ability, the program, how you write the code, how you modify, and how do you optimize the code so well, depending on the problem statement. So if you are able to solve DSA problems, then it is like almost all 60-70% of the chance that you will get hired. Okay, so it is very important skill, but anyway it can be achieved only using 3 key points. So most of the times you might have or felt that, okay, I know about this algorithm, I know about this data structure, so whatever they ask, definitely I can write the code. That is the like overconfidence. Okay, so right, let us assume if you without practicing, if you assume that the complexity is x, and then actually when you are asked to write on the paper, the complexity gets increased to 10x. Okay, so it is not so simple when you try to write on the paper about the algorithms or the code. It does not move if you have no practice. So main 3 key points here we need to remember, that is like a master problem solving patterns. So you identify the DSA problems into some patterns, and then you practice them a lot. Okay, and the consistency is the key here. It's like you always practice it. If the problem here with the DSA is like you need to remember the things. If you give some gap like 1 month or 2 months, there is a more chance that you may forget about the logics, and you may know about the core topics, but you may forget the logics, how to write the code, because it needs a lot of consistency. Okay, because when you keep on solving the questions from easy to medium to high, the difficulty gets increased. So for that you need to practice every day. Okay, so and then the third point is like you always need to analyze your code. So I spoke to many of the Google interviews or Microsoft interviewers. So they also say that whenever an interviewee writes the code, he should be able to explain what he is writing. Sometimes we actually get into some phase like we do not know what we write. Usually we forget what is the problem statement asked. We get into some loop, we erase and we write the code again. So lot of these are the very common things happens in interviews. Okay, so when we when we are very good in fundamentals, so like then writing and writing the code would be more easier. Okay, so coming to data structures, so in these are the most famous and frequently used data structures, like a stack, heap, queue, and trie trees, and hash tables, um, binary tree, min heap, max heap. So these are all the frequently used data types, right? So whenever a question comes to your mind, then you should be visualize any of these data structures. Okay, to solve this problem, I need a stack. Maybe to solve something like BFS algorithm, I need a queue. To solve some of the problems related to like k largest elements from the group, then min heap or max heap is required. Okay, so try tree, let us say if you want to store some content related depending on their name, then try tree is appropriate. So whenever you practice a lot, then immediately whenever you hear about some problem statement, you can be able to relate to any of these data structures. Okay, so um, so whenever it's like when you choose a problem, so solving a problem, you need to choose a data structure and you need to choose an algorithm, and then you need to analyze what is the big O. It means like, okay, to solve this problem, what is the time complexity or uh, and space complexity. Okay, so these are the data structures: arrays, linked list, stack, queues, hash table, binary trees, heap. And so here you can see like heap is like a min heap or max heap, graphs and trie trees, disjoint sets. These are all the data structures which are frequently used. Okay, and then these are all the like big O notions. Like okay, when you come to array, when you need to access using an index, the complexity is the complexity. Big O is nothing but how many times you traverse in the loop. Okay, so for example, you have an array. Suppose you have an array of, suppose you have an array like a 0, 3, 12, 1, -10, like that. Suppose if anybody, so accessing is nothing but, just a second. Hello, Mash. Oh, okay. Just, yeah, yeah. Okay, so till what time the session will be? This is a question. Like it will be there till 4:30. So as per that, you can plan. Okay, I'm sorry. In between, my the screen is not shared. Now I hope you can see my screen. Okay. Okay, fine. So accessing is nothing but like a of 0. So directly this data, this values are stored on the memory contiguously, so that whenever you call a of 0, immediately it goes here and access this element. Okay, so whenever you write a of 4, then it goes to this position and access this element. So what is the complexity of this one? Of 1. Okay, so you, for example, I want to search for number like 12. Okay, so what do we do? So we need to write for loop, and the I, this is like a pseudocode. I starts from 0 to length of that. So the length minus 1, let's say here it is 4. Okay, and if we need to check if the element, so let us say this is an element. So if then element is equal to a of I, then break it and tell that, hey, this is the position where I can see the number. So what happens? Until then, it has to start. The starting point is like this, so it has to go one by one and checks, yeah, here 12 is there, and then then this breaks. Now you see the for loop, it starts from 0, then it goes to 1, and it goes to 2. So when it reaches 2, then it finds the number. What if the number is not there in the array? So in that case, it has to go till 0, 1, 2, 3, and 4, and finally it says that, hey, number is not there. But by then, how many iterations, how many times it shifted one element to another element? It is 5 times, right? So the complexity of searching in an array is O of 5, nothing but O of n. So here n is nothing but the length of the array. Okay. So for example, if you need to delete an element from the array, then again it is O of n. So because it has to search all over the world, all over the elements. So if you have likewise, like let's say come to, let us take one problem statement that you have to manage a list of names. Let us say David. Okay, okay, Sri. So though so many names are there, if you try to maintain in this in an array, then what happens for searching? Um, so it takes O of n. So if this array size is 1,000,000, then it takes 1,000,000 times. So to shift from one element to another element, if it takes some x seconds, so then it takes these many seconds. Okay, so it is huge. I mean, if this is the problem statement, if you need to store the names in the array, then it is a big problem. So how do you store them? Maybe you need to use try block, try tree, so that you can save all the names in different branches. Okay, so it looks like a binary tree, but it is a multiple tree. Okay, so this data of the list of the names can be saved in these trie tree. Okay, so then the complexity can be O of k. K is nothing but the length of the name, length of the max name. Okay, so here D will be there, and here it is distributed like D and A. After D, and let's say here is S, and here let's say I. So it is all like this. No, if any name starts with a D, you have to traverse in this way. Okay, and if after D, if any name starts with A, then you have to traverse like this. So likewise, it goes till the length of your name. So whenever David is found, so here you can see there is a name David and all the details you can see. Okay, so the details about David can be seen in this node. So how many traverses we need to make? It is the length of the name, nothing but k. Okay, so k is the complexity of trie-tree. So depending on the problem statement, you need to choose what data structure is suitable for you. So that is about array. Coming to linked list, suppose the linked list, you can see like this is the starting node and it is pointing to the next node and it is pointing to another node. Finally it may end, it is null pointer, null pointer. Okay, so if you implement using C language, so it is mentioned as null, right? And if it is a Python, then we can write it as none. Okay, so what about the inserting an element? So to insert an element, what is the complexity of that? Suppose there are already some numbers 10, 13, 3 like that. So if you want to insert any element at the beginning, so suppose a new value has come, that is 15, so you can insert that 15 number at the beginning and you can direct. Okay, so what is the complexity of this? Big O of 1. Suppose again if you want to search about any element, okay, so in that case what happens, you suppose I'm searching for the number 3. Okay, so you need to search, you need to first take this one and go to its next node, next node, next node, and finally you come here. So by the time, how many iterations you have done, so that is nothing but the length of the list. So length of the list is here it is 4. So for searching, the complexity is O of 4, nothing but O of n. Okay, so this is about list. Of course, while if you want to delete, if you want to modify, for all of them the complexity is same, O of n. Okay, so likewise you need to have some hands-on all these data structures, how to write, how to insert the node, how to search for the node, delete the node, modify the node in linked list. What about arrays? What about binary tree? What about stacks and queues? You need to write some programs and first you get hands on these data structures. Okay, hash tables, binary trees, and verse and average. There are balanced binary trees, there are unbalanced binary trees, heap tree like a min or max. So all these, you can see the table here, right? So you can write some small programs like all these things, like searching, inserting, deleting, and maybe you might have already practiced in your academic years. So same thing, you can again repeat them and really find, yeah, is it really the complexity is O of n, log of n, is it O of 1 or O of k? So you can try analyzing you all these data structures with the simple programs and find out the complexity of that. So whenever you write the program in interviews, they will definitely ask you to analyze the complexity of your program. Okay, so in that case you should be able to answer them. Otherwise it shows that you do not know what you are doing. uh, that is somewhat a negative wave, right? So um, getting the better idea, keep practicing more with the sample programs for each data structure is a key thing. Okay, so once you get hands on this, once you get a grip on this, you will know that where to use these data structures. Okay, so some of the problems you may get confused between the selecting the data structure, so you need to select the best one. So after studying a lot more on data structures, you need to come up with some problem solving process. Like there are some steps. So whenever the question is asked, usually the biggest mistake is like they directly jump on the solution. So they directly start writing the code without putting any analysis on paper. If you try to write the code directly, then definitely you're going to miss the logic or you will be confused. So there is a saying that like when you before you come to me, put the problem on paper. So almost all like 90% the problem will be solved when you put your problem on the paper. So it is not only related to these interviews, it's a common thing. Okay, so once you put your pen on paper, then you will start thinking and your thought process will become better to solve that problem. Okay, so in this process, what is the first thing is like analyze the input format. So how are they giving me the input? Are they giving me in an array? Are they giving just an integer? Are they giving like a binary tree? Are they giving linked list? So first you need to this is the first point and it will be mostly clear, but keep it in mind. Okay, they are giving the data in linked list and okay, not an array. Then the way I access the data will change, right? If they give me the data in min heap, then the way I proceed with the problem solving will change, right? So first you analyze the data, analyze the output format. Okay, so for example, they may ask you to give the indices. Let's say they have given some numbers and they want to get the uh, highest sum of two numbers. Okay, so they in that case the problem is like they asked for the two indices. And another case is like give me the sub array where let us assume that you are you are going to book a train reservation. Okay, so you want to book the for four people. Okay, so this is your problem statement. So assume that this is an array, and in an array there is like a 1 1 1. It is like you can assume that this is a seat number. So let us assume the seat number starts from 1. This is 2. Yeah, 1 1 1 means it is all filled. 0 means it is not filled. Okay, so now I want some seats where I can get the consecutively 4 seats. So you need to find the start offset. Let us assume this is 3 4, and you should give the seat number. You should allocate the seat numbers from 5 to 9 to whenever user books the train reservation. Okay, if there are no seats, contiguous seats are not available, let us assume this is the one, but still you need to break that, and you need to give better combinations. Okay, so you allocate 3 4 here and another here. Okay, so or 2 here and 2 here. So depending on the statement, I mean the application, you can allocate and give that. But while returning, what you need to give, you need to give the list of starting and end points, right? So 5 comma 8, and let us assume this one is 10 11 12 and 12 comma uh, 12. Okay, it means here 3 seats are available and here 1 is available. So you need to return this list as output. Okay, so this is like analyze how you need to provide the output, what is the format, and decide how to keep the temporary data. So any problem you see, you yeah, any problem you see, you have to keep some temporary data. It's like you keep some queue or a stack or some pointers or indices. These are the this is the information you need to keep. So what do you need to keep? What is the cache? It is like a caching. So but that is not an output or neither input. So it is like until the program runs, you need that data in your RAM. Okay, so what temporary data you need to keep to solve that problem. So that has to be very clear, and analyze the complexity. Okay, once you come up with the uh, here actually deciding right, here you'll choose some data structure to keep the cache data. Okay, and to go through the input data, you have to come up with some for loops and if conditions or some algorithm to how to go through that. Okay, so after designing that, you know the data structure, what to be used, and you know the logic, what to be how to go through that, and then you analyze the complexity of that, what is the big O of that. Okay, so and then write some pseudocode. Yeah, once your algorithm is analyzed, you check with you check about the complexity. Sorry, you need to write some pseudocode. Okay, and then you define the test flows. Some of the cases, like let us assume that if I write some code and I'm ready, and so book for 4 okay is passing, but if I try to book for 0, then immediately your program crashes. There could be some reason. The reason is you're not handling the corner cases. Suppose if I book for -10, so what is the problem? So here you should actually return the error, but depending on the number you try to access it, and you may do some other issues, and finally it crashes, or your program may run into infinite loop. And again, that is a problem. That is another case where you have you have written the code in almost all the positive cases, and what about the negative cases? 0 is given, -10 is given, or some huge number is given. What do you do? So these are all like you need to come up with the test cases to which covers all the corners. Okay, so then so the we assume that any candidate who writes the code and also writes the best test cases for his code will be a better engineer. Okay, so you need to come up with the test cases, and then yeah, you will identify, definitely you will identify some of the issues where you have to do some changes. Then you start writing the code. Okay, so for all these until this is writing the pseudocode, it let us assume the time is given like 30 minutes. So you need to at least spend for 10 minutes or 15 minutes to until pseudocode. So the problem is directly the people come to the write perfect code. Okay, so they directly jump on this one instead of analyzing all this. Yeah, they may get some idea on input format and output format, and among they skip all these 4 steps, and they come directly writing the perfect code. So that is a big problem. Okay. Yeah, so these are all the slides about that. Analyze the input format and analyze the output format, decide how to keep the temporary data, analyze the complexity. There are 2 complexities, like a time complexity and space complexity. Space complexity is like how much memory are you using temporarily. That is also very important thing. So if you consume more space, some of the devices, they are like more constrained about the space or the memory. So in those cases, um, you cannot write the program which consumes huge memory. Okay, so you need to come up with other ideas. Depending on the target, you need to come up with some other ideas. Some of the times, if you write the code in lead code, it actually fails because of space complexity or because of time complexity. So lead code is, I mean, sometimes when I use it, it actually gives the better idea on my algorithm. So how better it is, how well your program compared to others in case of space complexity or time complexity, it gives a better idea. So you can use lead code. If any other platform supports, good, you can use that. Always analyze your the efficiency of your program. So define test flows. So and write perfect code at the end. So if you follow all these steps, the most of the confusion will be rectified. Okay. So of course, to go through all those steps, you need to have better an idea on on some of the data structures. Okay, so there are at least 10 patterns which are frequently used. I mean, asked in interviews. 10 are like array manipulation, 2-point sliding window, binary search, linked list, stacks and queues, trees and binary trees, graphs, dynamic programming, sorting and searching. So in this session, it is we are going to cover almost all these 6 patterns. Okay. So array manipulation comes like you know how the array gets allocated, right? It is a contiguous memory. So here you can see 2, 4, 10, 5, 15 are there. So and you can access using indexing, right? So this is the basic idea on array array arrays. Okay, so you need to work on arrays. So approach is like, so suppose if any question is asked like 2 sum, okay, so return the indices of 2 numbers adding to the target. It is like you can, yeah, you can assume that there are meeting rooms. Okay, so there are meeting rooms like the time that the time is like so 10 hours is there in the in first meeting room, a free time, and sorry, not 10, let's say 4 hours free time is there, and there is 3 hours, 1 hour, 0 hours, and 5 hours, and 3 hours, like that. Okay, so these are all the like some list of meeting rooms and the available time. So suppose I want to allocate allowed 6 hours session. I want to allocate 6 hours in any meeting room. If um, I know there is no room for 6 hours continuously available, but okay, fine. You can choose any of two rooms which meets 6 hours my target. So how do you go through that? So assume that the here this is the input. So input is an array. So 4, 3, 1, 0, 5, 3 like that. Okay. So input, what is the output? Output is like you need to give two indices I comma j. So you need to give I comma I and j. So what do? You know the target. So this is target. Okay. So this is t and this is I. So we start in for loop, in one for loop we start I from this index. Okay. And j you can start from this index. Okay. Now you check what is the sum of these two. Is it equal to 6? No. Okay. Then you shift j to here. Okay. What is the sum of 4 and 1? No, it doesn't match. Okay. Shift again j here. It doesn't match. And shift here, no, it is not matching. So it's like you write the for loop for I in range of, I'm going to write the code in Python. So range of some, let us assume this is length 5 6. Okay. So n is equal to 6, so it's 6. Okay. So that when and then I start from here. So I is here and j should complete one cycle. Okay. So this is the big cycle, and inside what is the cycle? That cycle is for j in range of, it should start from I plus 1. It means the j should start from I plus 1. Okay. So I plus 1 and the range is n. Okay. So here if array, if it is an array, a of I plus a of j is equal to the target, then break it, break, and whatever I and j are there, you return them. Okay. So or you can say you can return I comma j. Okay. So what is this? This is the first for loop. For each value of I, j has to finish the numbers from I plus 1 to n. Okay. So what is the complexity? By the way, what is the complexity of this one? Anybody on chat? So can anybody answer like what is the complexity of the this algorithm? Okay. So the complexity of the algorithm, we can say n square. So the complexity of the algorithm, right? The reason is here I is going from 0 to n, and for each I, the j is going from I to n. Right. So so it's like when I is equal to 0, then j has to complete 1 2 3, 4, 5. Okay, and again when I is 1, j has to go from 2, 3, 4, and 5. So this is n, and so this is like I is changes from 0 to n, and the for each time it is almost, it has to go n minus 1 times here, n minus 2 times, n minus 3 times, and minus 4 times, like that. Okay, so overall the complexity of this time is of n square. Okay, so can we find any better solution for this? So this is the, like, I know what is input and I know what is output, and I've written some pseudocode. Now I have analyzed. Okay, so if the if now I'm analyzing the complexity. The complexity is n square. Okay, so if this is the complexity, then interviewer may ask you to optimize a little further. So how do you optimize that? So this is our code, what we have written. So what is the time complexity here? Of n square. What is the space complexity? Are we using any memory here? No, hardly we are using I and j, that's all. But no, not like using the arrays or queues or stacks. Okay, so that is why the space complexity here is 1. This is optimized code. Here is like we can have the array in different way, like the different approach here is like, that is the reason you analyze the code, analyze the complexity, and can you improve this algorithm little further. So sorry. Okay, so here you can see we can have an array. Suppose the target is 6. Okay, so the previous problem statement is like we are using 2 for loops, one for loop for I, another for loop for j. So that is the reason the complexity of O of n square. So can we reduce further? So we can reduce further. That is like you can keep the differences. Like let's say I'm going to create another array, that is I'm subtracting the value from 6. So 6 and 4, what is the value? It's 2. 6 and 3, 6 minus 3, 3, 6 minus 1, 5, 6 minus 0, 6, 6 minus 5, 1, and 6 minus 3, 3. So this is the difference table, diff table. Okay, so in first for loop, so first for loop I'm going like this: for I in range of length of a, and I'm going to take an diff table. Okay, so diff table of I is equal to t minus a of I. So like we can have the list of differences. Okay, so how much time does it take? O of n. And suppose now I'm going to write another for loop, that is again I in range of length of a, and I'm going to put the if condition. Now I go I go through this 4. Now 4 is taken, and if the 4 plus 2 is equal to target, then I it is I can stop it. Okay, so sorry, I'm sorry. So what I'm looking for here is like 4, and wherever the target, like so if a of I plus diff of I'm sorry, if a of I is equal to diff of I, then it is like I found the index. So for example, whenever I come to this position and 3 is here, and if this one is equal to, so other than its own position, if this one is equal to here is this one, okay, so diff is 3, okay, so here I can break the for loop. Okay, so what is the complexity of this one? O of n. So here O of n plus O of n, the total result is like O of n. Okay, so but what is the complexity of the space? So this is extra space. Whatever the difference I have used, this is extra space. What is the complexity of this? This is again O of n, because I'm unnecessarily creating a duplicate of the same array, and that is n elements. So that is nothing but this is a space complexity of O of n, and the time complexity is O of n. Okay, so in this way, like we are consuming more memory, but unnecessarily we are of course to optimize the time, but we are consuming the memory. Is that okay? So this is another logic how we keep the, so lookup is like keeping the difference. Okay, so we this one and this one is the same logic, and whenever it finds that so complement is there in lookup, that nothing but whatever the number you are there, if it is there in diff table, then break it and return that I and j. Okay, so similar problems we can see, like remove duplicates from sorted array. Given an array, remove the duplicates in place and return the new length. And maximum subarray, find the contiguous subarray with the given largest sum and return the sum. Okay, so these are all the similar problems can be solved in using um, um, by using this is the same pattern like a two sum problem. Okay, so yeah, coming to 2 pointers. Are there any questions so far? If you have any questions, you can ask. Okay, there is another pattern. So in this session, we are going to discuss about this one before we close the session. Okay, that is related to 2 pointers. 2 pointers is like, suppose when you have an array, you can have pointers, which is like the set at the ends of the array. Okay, so for example, So 2 pointers pattern, it looks like this one. So if there is an array, okay, so assume that this array is sorted. So it works on sorted arrays. Let's say 1, 4, 7, 8, 12, 20, 30, sorry, 40, 50, and 70 and 80. Okay, so 2 pointers you can see, like this is a start pointer, yes, and this is end pointer. So depending on the condition, this start pointer moves towards right and the end pointer moves towards left. Okay, so let us see the approach used when the data is sorted or can be sorted. So these 2 pointers works on sorted arrays. Okay, so place the pointers at strategic ends. So one is at the end, one is at the start beginning, and make pointers inward and outward based on the condition. So either you move based on the condition, you move this one left or this one right, left or this one right. Okay, and track the current best while updating. So one of the problem statement is like you have the containers with the most water. So it is like assume that you have, so here one is like I'm going to draw the walls as per the numbers. So this is floor and this is 1 and this is like 4, 7, 8, 12, 20, 40, okay, 50 and 70 and 80. Let's say the problem statement is like, hey, if I take any of 2 walls, the max, you should be able to keep more water if I choose any of the 2 walls. Okay, so I need to choose the best wall and then I need to return those indices. In that case, what should I do? I keep one pointer here and I keep another pointer here. Okay, so now what is the, how much is the maximum water I can keep? It's like the maximum water I can keep if the I is at 0, I mean sorry, start is 0 and end is, let's say it is 1, 2, 3, 4, 5, 6, 7, 8. So end is 9 at 9 offset. Okay, so now the max can be contained, max volume is equal to, assume that this is A. Okay, so A of 0, A of S, so it's like minimum of A of S comma A of E. So we get the minimum of that. What is the minimum between this one and this one? So this is minimum, right? So that one into the difference between that. Okay, the difference between these 2 walls. So what is that? 80 minus 1. So this is the you can keep the water just till this level, right? So till 1 you can keep the water. If the water level goes up, it will be overflow, right? So what is the maximum you can keep? So that is like sorry, this one is not 80 minus I, it is the difference between this index and this index, nothing but 9 minus 0. So this is the maximum volume they can keep the water. Okay, so we keep on moving. So you keep moving from here to here, and then you find the what is the maximum amount of water you can get. Okay, so if the volume, so suppose if it is moved here, now the number is 4, right? And now if you see if the volume is more, then you keep on moving the this pointer. So if you are able to increase the volume, then you keep left side, you move the s towards right side. If the volume is reducing, so we always keep what is the maximum. So you keep the note of what is max you can have. So depending on the current positions, you calculate what is the maximum value you can keep. If it is less than max, then move this pointer to left side. Okay, and if it is moving more than this, then you keep on moving uh, to right side. Okay, so these playing between these pointers, moving left and right, will give you the solution. Okay, so this is the code, like, yeah. So to solve that problem. Okay, so this is like, what is the best is nothing but, okay, we are keeping the best. I j are like some temporary variables. So you find you calculate the j minus I into minimum of this one. So you get the volume, how much you can keep. So is that better than best? I mean, more than best, then you keep that in best. Okay, so here you are always keeping updating the best, and you are depending on that you are moving I or j. Okay, so what is the complexity, time complexity of this one? Of n, and space complexity of is 0 1. So because you are not consuming more memory, you are not using temporary array, you are not using temporary queues or stacks, so that is the reason the space complexity is 1. Okay, so likewise there are other patterns as well. In the interest of time, I'm going to stop the session today. So the remaining patterns can be discussed in coming sessions. Okay, thank you so much. If I'm very sorry because it started very low, very late, and yeah. So if there are any feedbacks, please leave in the comments. Thank you so much, and all the best, and we'll see you in next sessions.